All right, so we're moving on to section 3.1, part 2. Still working with integration by parts. Just this one is going to have some a little more involved integration, a little bit more difficult. Maybe a few story problems in there as well. So for example number 1, and not too difficult of a one, start off a little bit easy. So, oops, that's not what I wanted. Okay, so let's review here what our equations are for integration by parts. We have the integral of u dv is equal to uv minus v, the integral of v du. Okay, so that's our equation. And also our acronym that will help us choose our u value. All right, so integration by parts to evaluate the integral 5t cosine of negative 8t dt. So this one we've got an algebraic equation and a trig equation. So we are going to choose the algebraic equation to be u. So we are going to say u is equal to 5t, and then we need to choose dv, and dv is everything else. So cosine of negative 8t dt. All right, and so integrate, well, let's start over here. So let's find our integral first. So take the integral of u, and that's going to be 5 dt, and then integrate dv so that we can find v, and the integral of cosine is sine, but we also have to remember that chain rule. So negative 1 over 8 sine of negative 8t. Okay, and then yeah, we would have a plus c there too, but we're going to just combine all of that in the very end. Okay, now we're ready to do our equation. So the integral of u dv is equal to uv, which is going to be 5t times negative 1/8 sine of negative 8t, and then minus the integral of v, which is negative 1/8 sine of negative 8t, and then that's v, and then du, which is times 5 dt. Okay, so we've got a lot of cleaning up we can do here. So let's get, I'm going to go ahead and cancel out these negatives right here. That's something I can do there. And then let's start combining this first term. So we're going to end up with negative 5/8 t, and then sine, see if I can actually write so that you can read my writing, of negative 8t plus, let's see, we're going to have the integral of sine of negative 8t. We can pull that 5/8 out in front. And then once we integrate the sine of negative 1/8, or negative 8t, we're going to pull out a negative 1/8 out in front. And then the integral of sine is going to be negative cosine of negative 8t All right, so lots of negatives there again. We got our 5 pulled out in front, so I think we're good with everything. And then a plus c. Okay, so we've got negative 5/8 t sine of negative 8t. Those negatives will cancel, so it looks like we'll have plus 5 over 64 cosine of negative 8t plus c. Yep, and so that's our final answer for example number 1. Okay, so for example number 2, use integration by parts to evaluate the integral ln of s 7s plus 1 ds. So this is just kind of a tricky way that we can use this integration by parts. So let's write up what our equations are up here. So we've got the integral of u dv is equal to uv minus the integral of v du. Okay, and then also remember our little acronym here, LIGHT, that can help us remember the order. So we have, oh actually that's not even going to help us any because we have logarithmic function and that's it. So yeah, we're going to set the logarithmic function equal to u. And then dv is going to be everything that's left over. So we get u, I'm going to write this up here because this one's really long. I actually already tried to do this once and I ran out of space really bad, so I just started over. So we've got u equals the natural log of 7s plus 1, and then dv is equal to ds. So all of this actually seems pretty nice. I can't say that the whole problem is nice though. So the derivative of the natural log of 7s plus 1 is going to be 1 over 7s plus 1. Then don't forget your chain rule in there, so we got to multiply by the derivative of the inside, which is 7, and then ds. Right? And then we got to find the integral of ds. So, or the integral of dv, which is just s. Okay, so now let's go ahead and write down our equation. We've got all of that is equal to u, which is the natural log of 7s plus 1, times v, which is s, minus the integral of v, which is s, times du. So we have 7 over 7s plus 1. All right, and then ds. So we did a problem kind of like this equation. It was quite a while ago when we were first doing integrals, when we did u substitution. So I'm going to do u substitution, but since I've already used my u's and v's and what we normally use for u substitution variables, I'm going to use a z. I hope that's not too confusing. So we're going to say z is equal to 7s plus, let me clean that up, 7s plus 1. Okay, then dz is equal to 7ds. Oops, that's going to quit writing on me for me. Give myself a little more room. Okay, so dz is equal to 7ds. Ooh, I did it. Okay, and which is good. So we have a 7ds. So see that we've got all that 7ds. So that's going to be dz. So we're good for dz. However, we're still going to have this extra s out here. So remember when we did this before, what we did was we go in and change our z and solve for s. So z minus 1 divided by 7 is equal to s. Okay, now we can use all of this to substitute back in here for our integral. I'm going to forget about this for a minute, hopefully not by the time I get to the end. But I'm just going to kind of leave that there. We'll come back and pick it up here in the end. So I've got a negative integral, and instead of writing s, I'm going to write z minus 1 over 7 times, remember that 7ds is all dz, over 7s plus 1, which is z. Okay, so now we've completed all of our substitution. So now, trying to think here, let's go over here. So now we've got minus, we're going to multiply all of this together. So now we've got minus, let's pull the 1/7 out, minus 1/7 minus 1/7 times the integral of z minus 1 over z integral dz. Okay, which then, keep following along here, is -1/7 times the integral of 1 minus 1 over z dz. Okay, which is then -1/7 times the integral of 1, which is going to be z, minus 1 over z, which is negative natural log of z. Better put absolute value bars on there. And yeah, then that's it. So we finally got all of that. Let's plug our z back in, and now we'll be able to put our equations back together again. So we've got -1/7, and I could have done this a lot shorter. It skipped quite a few of those steps. I just want to make sure and get them all in there. So z, which is 7s plus 1, minus the natural log of z, which is 7s plus 1. I'm going to run out of room here. So pretend that's a 7s plus 1. All right, now let's go ahead and write out our whole equation. So we've got, my answer is the natural log of 7s plus 1 times s. Let's go ahead and put that s out in front. So s times natural log of 7s plus 1 minus -1/7. So we can make that minus plus. Yep, because there's two negatives there. So plus 1/7 times 7s plus 1 minus the natural log of 7s plus 1. And then all of that plus c. Now let me check my answer here, make sure we got all of that in the clear. Okay, it looks like on mine I went ahead and multiplied the 1/7 through. Yeah, okay, so I'm going to go one more step here because they did do something a little different, and I'm not sure I didn't plug it in this way to see if my open math would accept this. But we can multiply this through, and so then we get plus s plus 1/7 minus the natural log of 7s plus 1, and then plus c. So what they did here is they took this constant, because we've got 1/7 and c, and they just added them together, so you can take the 1/7 out completely and combine it with the c, and then this becomes your final answer. This comes back. Okay, let's see. And then that's your final answer.